on IB continuous functions in supra topologies. This video is almost entirely based on the paper by Hibar Omar Musa Al-Tikrity that was published, as you can see here, in Turkish Journal of Computer and Mathematics Education. So the vast majority of notions and symbols and, of course, theorems and definitions is taken strictly from this paper. We just changed, well, several symbols maybe, and of course we omit proofs and details. The whole paper refers to the initial notion of supra-topological space in the sense of Mashur. Supra-topological spaces are just like Chasar's generalized topological spaces, but with the assumption that the whole universe is open. So the whole universe and the empty set are open. I mean that they belong to the family of open sets, and this family is closed under arbitrary unions, but not necessarily under finite intersections. So the idea of supratopology is somewhat weaker and wider than the idea of topology. We say that a supratopology mu is associated with a topology tau on X if tau is contained in mu. Now we need several additional notions. A subset A of a topological space is I open if there exists open, in the sense of topology, set O, which is different than the empty set and the whole universe, such that A is contained in the closure of A intersected with O, and its complement is I closed. Few months or maybe even years ago, I made a video about I-open sets. It's available on this channel. Moreover, there was a video about so-called II open sets, but they are not mentioned here. Another definition: supra semi-open set in supra-topological space is just like semi-open set, so it means that A is contained in the closure of interior of A, but with respect to the supra-closure and supra-interior. Then we have supra B-open sets. It means that A is contained in closure of interior of itself, and I mean in terms of union, in the union of closure of interior and interior of closure, but with respect to supra topology. And its complement, as always, is supra B closed. Al-Tikrity defines a new class in the following manner. Assume that we have a supra-topological space. Then we say that A is supra-IB open if there exists supra-B open set O, which is different than empty set in X, such that A is contained in the closure of mu, closure with respect to mu, closure of A intersected with O. And of course, we have supra IB interior and supra IB closure defined in a standard manner as the union of all IB open sets contained in A and an intersection of IB closed sets in which A is contained. And IB interior is supra IB open and supra IB closure is supra IB closed. This new class of sets, I mean IB opens, supra IB open sets, is a double generalization of the notion of I open set. Double, in the sense that, first, we replace topological openness, topological interior with supra topology. Yes. So it's written here if there exists supra, and moreover, not just supra open set, but as we can see here, supra B open set. So it's just like a kind of combination of B open and supra open and I open sets. The author proves several claims about these classes, like, for example, some of them are trivial, of course, that A is contained in its IB closure, that interior with respect to supra IB is contained in A, that the union of supra IB interiors is contained in the interior supra IB interior of union, analogously for closures, as you can see here. Moreover, every supra B open set is supra IB open. However, the converse is not true, so you can discuss this counterexample. Rather simple, which is here, but well, at first you should check which sets here are supra B open and supra IB open. As always, we omit the proof. And moreover, every supra semi-open set is supra IB open. And again, the converse is not true. And again, we have a kind of counterexample that should be analyzed. Assume now that we have two topological spaces. One is X with topology tau and Y is the second one with topology sigma. And we have mu, which is a supra topologic associated with tau. Then we say that a function from x tau to y sigma is supra IB continuous if the inverse image of each sigma open set in Y, so inverse image of each open set in Y is supra IB open in X. Supra IB open, so yes, indeed, we need some mu supra topology. The author proves that every continuous function is supra IB continuous. And the converse, as you could guess, is not true. Every supra semi-continuous function is supra IB continuous function. The converse is not true. And analogous theorem, as the one here, can be stated about supra B continuous functions. Every supra B continuous function is supra IB continuous, but not the converse. Then we have supra IB open functions. If we have two spaces that are topological, then our function is supra IB open if the image of each tau open set in X is supra IB open in Z sigma. And there's certain characterization that is visible here. Yes. So the author proves this theorem, and similar definition and theorem are formulated for the notion of supra IB closed function. If we have three topological spaces, X, Y, Z, with topologies tau, sigma, and lambda, and we have two functions from tau to sigma and from sigma to lambda, then the author proves that if the composition G of f of x is supra IB open and f is continuous surjective, then G is supra IB open, and this condition here can be, we may replace it with the assumption that G is, but now supra IB continuous surjective. There are other characterizations and theorem in this paper. You can check it. Here is the bibliography. This is the paper that was crucial for this video. And then we have other papers about I open I sets and I open sets too. Thank you for your attention. Goodbye.